SMT Nation, we back. In today's video, we're going to be, testing a hotspot feature. All right, this specifically, we're going to be testing the XFINITY mobile service. And the reason why I want to do this is I want you guys to kind of have a gist as to how the mobile hotspot and tethering performs on XFINITY Mobile. Just a little bit of background information here. We're testing two iPhones, the iPhone 12 Pro with the XFINITY mobile line, and then the iPhone 13 Pro, which will be connecting from the hotspot. And we're going to keep this real simple. We're going to keep the devices near each other so that we don't have any type of possible, misconfigurations or other variables that can impact the performance. I'm going to start first by testing the on-device data on the iPhone 12 Pro. It's got the XFINITY mobile line in there. 317 down, 14.5 up. We've got a 30 ping and just a couple milliseconds on the jitter there. Solid connection. We are on the C-band N77 for Verizon. Remember, XFINITY Mobile does use the Verizon network for its connectivity, unless you are on some of their hotspots and Wi-Fi connections that are available throughout many cities. And that was the ookla speed test performance metric there. And you'll see that on fast.com. It's like a totally different story sometimes. I don't know. The Verizon with the ookla speed test just doesn't work out well. It's always much better on the fast.com. You'll see here it's like 480 megabits downlink. All right, let's go ahead and get this thing connected. Let's connect the iPhone 13 Pro to the iPhone 12 Pro tethering and mobile hotspot. You'll see here I am going to just run the standard connection methodology. The nice thing about the features with the iPhone and the iOS, you get this share connection, allows you to bypass the password as long as you approve it from the other device. Very underrated feature, very convenient. I like it. So it makes it really nice, real easy. Went ahead and turned off the low data mode, and now we're just going to run, the 5 gigahertz connection. Best connection you're going to have going mobile and, tethering. All right, so you'll see here it does indicate that you are connected to the Verizon network. And, you guys will see here based on the performance, it's pretty daggone good. This is essentially the same speed and performance that we saw on device, which is awesome, right? 366 down, 15.8 up, 34 ping, just a couple milliseconds on the jitter. That's a solid connection for a tethering hotspot. All right, so how it compares to on-device, even a little bit better than it was before. I'd say that's just because of maybe momentary traffic on the network, but it's essentially the same experience. All C-band connectivity, it doesn't matter what plan, what carrier, what MVNO, whatever. All those connections are always going to be QCI 7 on the Verizon network. That's why you see such great speeds, regardless of the time of day and priority and all of that. Let's run a second test. This one even better. 433 down, 17.2 up, 34 ping, 2 millisecond jitter. Even the speeds are getting faster here. Again, I think it's more of a situation where it's maybe there's some momentary slowing due to just extra traffic on the network. I would assume that there are not only a bunch of 5G devices for mobile devices, but I think there's some people who probably even have the service, with the Verizon 5G home. So that could be all a factor here. 441 down. The uplink weak on this one at 3.7 megabits. Let's go ahead and do some fast.com, and let's compare how the on-device data with the tethering data does on the Netflix servers that connect for fast.com. All right, so we got 380 on the downlink. The latency says 0 on the unloaded. It says 54 on the loaded. I don't know how accurate that is on the fast.com app, but just throw that out there. About 14 megabits per second on the uplink there. Let's go ahead and run a second test. This is on the iPhone 13 Pro. This is the tethering and hotspot data. All right, second test, we got 330 down. The unloaded latency at 0 milliseconds. I don't know how accurate that is. 215 on the loaded. And then we're in the 11 megabit per second range for the uplink. Pretty good stuff. All right, now what we're going to do is we're going to kind of experiment just a bit. We're going to run the devices at the same time, see what that does to the connection. So I started first with the tethering phone. All right, the one that is actually using the hotspot. And you'll see because I started it first, it got more capacity available to it, more throughput. 441 down and 9.8 on the up. And then on the on-device, The XFINITY line direct, it's like 398 and about 18 megabits per second on the uplink. So an interesting, thing there, right? One started first, finished first, all right, but the ping time's almost the same, pretty close. Speed throughput a little bit different, and that, of course, because of the timing. When do you start each of the tests respectively? Whichever one starts first usually gets the priority. First come, first served kind of connection, right? All right, now let's go ahead and switch that. Let's do the on-device first, and then we'll run the tethered device, and we'll see if it makes a difference, and we'll see what type of capacity and throughput is available for each one. There's a 403 on the down as it finishes for the on-device XFINITY Mobile, and we got like 19, 18, 17 megabits. All right, you'll see that it does finish first, while the tethered device is kind of still going there, right? All right, so pretty much a standard connection. That's pretty much the performance we've been seeing. 387 down and 18 up on the tethered device, but you see the latency is much higher. We started the test second. All right, let's run the fast.coms, starting with the tethered device on the right. 450 down. Same thing on the tethering device, 450 down. So we got identical speeds. You'll see that the one that started first does have a better latency in terms of the number and the measure. To be expected at this point now, you guys are kind of seeing kind of what the case is. Whichever one starts first gets more capacity throughput, gets a better latency. And again, I don't know how much of this is actually like real world, right? We're testing using like speed testing tools. We're not really testing specific apps that actually have functionality. So like, how would this perform if we were actually watching Netflix as opposed to running a fast.com speed test? Maybe similarly because it runs through the servers. But you see there, 440 down on device, 34 ping, got like 21 on the uplink, and then 340 down on the tethering. So, all right, let's try it at the same time or about the same time. Let's see if there's any difference. All right, 29 ping on the left, 34 ping on the right. Okay, so that's interesting. You will see the one that maybe started first slightly does get the edge, right? 300 plus megabits. The one that kind of started second, 267 megabits. Uplink at 11 for the one that started first. I think the uplink in the single digits for the other one. I think it ended up catching up actually and closing that gap, getting up to about 10 megabits. So really it's just about timing. It's whichever one starts first kind of gets the pull or gets the capacity. So it isn't really about whether or not it's the device that's being tethered or doing the tethering. It's just like whichever one pulls first, right? And by the way, these phones were getting freaking hot. Well, the one that was hotspotting is getting hot. Modem's working extra hard. Anyways, tell me what you guys think about the testing. Comment down below. You are the voice of the people, the SMT Nation. Let your voice be heard. Like, share, subscribe for more. Turn on that bell notifications icon to never miss an upload. And we got all this stuff going on with the channel down in the description box. Thanks for watching. See you on the next one. Peace.